Okay, what was the most difficult, you ready?
We're ready.
What was the most difficult technical problem? I'm going to have to talk about several different kinds of problems. One of the problems was learning how to accurately predict how much payload we could carry. What could we load onto the Agena and still make orbit? And we obviously failed on that score early on because we Discoverer 3 and 4 didn't go in orbit because they were too heavy. The next class of problem was the problem that anything that went wrong in the spacecraft eventually resulted in the spacecraft going unstable. And so I guess our technical problem there was one, we had very limited telemetry back from the spacecraft, and so you tried to say what caused you to go unstable, and you looked at this rather rudimentary telemetry trying to figure out what caused the real problem. Now, frankly, the Agena itself in those days was a fairly simple thing. Conceptually, it was complicated because it had all sorts of wires and connections and the like. Did we make any big breakthroughs in that part of it? I don't think so. We learned how to operate it with all its limitations. We learned how to get around some of the problems. I guess if you're going to say what's the most difficult or the challenging technical thing is that unlike present-day spacecraft, which have all kinds of redundancy in them, it was essentially a straight-line series system. If anything failed along the line, the whole darn thing failed. So you didn't have any, you had only one attitude control system. And if something went wrong in the attitude control system, it went unstable. You had a limited number of batteries. If there was a short developed on the power bus, you went unstable. So you didn't have the luxury of saying, well, if this breaks, I've got that to fall back on. Everything from launch to separation had to occur, or nothing, or you didn't get the capsule back. It turned out, everybody thought that the most difficult thing was going to be for the airplane to catch the capsule when it came back. Well, that was really simple. The real problem was getting the capsule anywhere near the airplanes. And it took us a long time before we figured out how to do that. I guess, yeah, that's probably the best description of it.
That was good. That was excellent. Let's get in a little bit to the battle's laws. And one of the characteristics of the program, of course, was being very streamlined compared to the way we do business today. And what I'll do is ask the question, how did we manage the program from a program management standpoint then that's different from today? And maybe get into some of Battle's laws, for example, and refer to that.
Well, how did we go about managing and doing what we did is always an interesting thing to talk about. First, as I said, it was a very small program office. And so there were never any problems with coordination within the office because there were just 3 or 4 or 5 of us at the most. So we talked frequently, we knew what was going on all the way along the line. We did not create very much paper. It was all done, an awful lot of it was done face-to-face or on the telephone. There was not documented, and this turned out in retrospect, to be a real problem when people tried to write the history of the program, because there wasn't any paper that said anything about it. Now, Colonel Battle had a few, well, he had a bunch of stuff that he wanted us to do. And one of the things he said was, you have to select good people and give them responsibility and keep them about 110% employed. And so that was engineers and scientists only, no management experts need apply. One thing, and you had to be competent in something. And and then secondly, each of us had an area of our primary responsibility, and it was we also had to develop relationships with the various people in the supporting organizations. Guys that we could call and say, tell me what's happening, or tell me how this happened. So that was a second part of it. A third part of it was, and you look down through those, the typed law thing there, the typed battles laws that are around in various science. Some of them have gotten badly bollocksed up because people added things that they thought should be in there. But the original were fairly straightforward and short. Don't over-communicate with higher headquarters. Tell them what you think they ought to know, not what they think they want to know. And so that was a fairly standard practice in the office.
I know we can cut right now, and if you want to look at some of these.
Yeah.
You can either fix it or cause it. I don't. Okay, let's. Are we ready?
Yeah. You know what, sir? For consistency reasons, would you mind
Oh.
taking off your glasses? Thank you.
All right.
Yeah.
So
Who's
now
this?
you see them, now you don't.
Yeah.
Have any of that.
To talk a little more about Battle's laws, one of them obviously was hit every failure hard. Find out what the cause of failure was and make sure you fix it before you did it again. A second one, as I've already said, was there is no such thing as a random failure. The third one was you've got to be schedule oriented. When you set a launch date or a date, you got to work just as hard as you can to try to get there. And you have to keep the pressure on everybody so that you can get there. Another one was make the maximum use of all the supporting organizations that you can by keeping the program office small and making sure that all the supporting offices do their work. You're in the best of all possible worlds. Whereas if you have a whole lot of folks in the program office, then you get in each other's way. One of the guys in the Agena office used to say, it's obvious to me that the function of a program office is not to do work, but to be sure work is done. And he was complaining because he saw us, he thought sitting around, here he was working hard, and I thought, well, that's the way it ought to be. I mean, my job is to be sure you work hard, keep you fully employed, and sort of thing. We, as I said, we generated an absolute minimum of paperwork. We resisted any attempt to have committees or reports or anything like that. We concentrated on making the doggone thing work. And that was a full-time job, obviously, as we stumbled along. And I guess in retrospect, you can say that when we started out, we really didn't know what we were doing. But fortunately, nobody knew that we didn't know what we were doing, so they let us do it. And that worked out pretty well.
That's great. That's good.
That wasn't going to make it in.
That's
Yeah.
okay.
Let's see. Anna mentioned to me you went through with an excellent chronology of the different missions and what occurred, and then let's see on 13 and 14, the successes.
Yeah.
I think it might be helpful if you detail a little bit on those two missions, and within maybe 14, when you talk about 14, why don't you kind of talk about all the different elements, the things that had to happen? You know,
What went right?
yeah, the launch, you know, starting with the launch, the separation, the Agena performance, the attitude control, the stability, all the way through separation and catch. Just to give the audience
Well, is it all right if I start at let's see.
at 13 or 14.
Well, let's talk a little bit about 13, Discover 13 and Discover 14. I think I said earlier that when we got to Discover 11, we had figured out how to launch things, we had figured out how to control things on orbit. We had checked out essentially all of the things that were along the line. And on Discover 11, everything worked perfectly, except we didn't get a capsule back. Now, and that disturbed us, no end, because we thought we finally had gotten there. We then came back and we looked to see what we had to change in the program, and so in Discover 12, we did make a number of changes. We instrumented the capsule, we instrumented the separation sequence, and we made one other probably significant change in Discover 12, and that was our original scheme for spinning up the capsule after it's separated consisted of 4 little kind of skyrocket things that hooked on to the retro part of the capsule. And these 4 things were supposed to, 2 of them were supposed to fire to spin it, and then you had to fire, you fired the retro rocket, and then you were supposed to fire to despin the thing. And so there were 4 things that had to fire in addition to the retro rocket to make sure this thing came back. And we began to think that that wasn't a good way to do it. And so somebody said, well, instead of spinning it with a rocket, why don't we make a cold gas spin system in which you had a canister of gas, and you had 4 little nozzles out here, and when you fired you only had to fire open the gas valve, and then the thing would spin. So it simplified it quite considerably. And so that's what had happened. Now, as I said, unfortunately, 12 didn't orbit because of a problem with the Agena. Now, by the time we got to 13, we did all of that. The preparation for launch base had gone extremely well. The Agena, through the whole thing, had progressed nicely. Our launch from Vandenberg was pretty much on the money.
Sir, I'm sorry.
Yeah.
Can I interrupt? I'm sorry. Can
Yeah.
you take it back to by the time we got to 13? I'm sorry, because we had just a little coughing interruption. And I really like this. It's beautiful, and
Okay.
hopefully it'll be in this
There's
video.
water with their bill,
Yeah, there's
seriously.
some water. I'm
Yeah.
sorry. So by the time we got to 13, that's
Yeah.
where we were. I'm sorry. I wish it could be very casual and very natural, but it can't. Because when those folks are sitting out in the audience and all of a sudden they hear.
You mean I'm not gonna make it into the video?
That's right, you tried.
I've been planning this all day.
Well, by the time we got to 13, we thought we knew pretty much what we were doing. We'd gone through the launch sequence 13 times. The crew was well trained and all that, so the work at Vandenberg went very well. The launch was, as I would call, fairly routine. The separation was good, and we did all the tracking that we were supposed to do. The satellite control facility had worked it out so if we didn't get exactly the orbit that we needed, they could control things properly, unlike on Discover 2. And so everything went nicely, and we ran tests. Our telemetry worked. We got all of our good telemetry on the thing. And well, I guess I ought to digress just a little bit. The satellite control facility at this time was limited to Kodiak in Alaska, Annette in Alaska, Vandenberg, and Hula out in Honolulu. And that meant we saw the bird only on the first 2 orbits, and then we didn't see it again for 6 orbits because we didn't have any East Coast tracking stations. So we were essentially out of contact with it for about 8-10 hours. So we were delighted when it came back and everything was still working right when it came back, and everybody was quite happy about that. And all we hoped was that we could make it through about Rev 15 or 16 when the separation was supposed to occur. So on 13, it came over Kodiak, and the separation went through. And for the first time, as I said, we got an indication, a direct indication that the capsule had separated. And then again, for the first time, we had telemetry in the capsule, rudimentary, but it said it had spun and the retro rocket had fired, and I think that's about all we got. But the ships and the airplanes that were underneath the flight path did pick up some of the S-band beacon. Well, at that point, frankly, we all kind of relaxed because we said physics takes over. We've done this, it's going to come down, and it's going to come down about where it's supposed to. And lo and behold, physics took over, and it worked, and it came down. It came out of the ionization layer, and the airplanes picked up the little beacon that was on board it very quickly. And this is the first time we had ever heard that beacon. And so everybody was elated at that point. And so then it was simply a question of would the airplanes catch it? Unfortunately, they didn't, as I said, because of the equipment problem. But basic flaw in the design, not anything else. I mean, they had antique direction finding equipment, not modern stuff, and that's why they flew off the wrong way. So they were very unhappy that it didn't come in, that they didn't catch it. So it came down, the Navy picked it up, Moose went out and took it away from the Navy and brought it home, and it went through all of the rigmarole of the publicity and all the rest of that. And all those guys went off to Washington. And we were left out here to get Discoverer 14 ready. So while they're all back in Washington doing things, we're out here working to get Discoverer 14 ready. And it went off and worked very well. And again, this is the second time that the payload had actually worked. And so we knew that we passed the appropriate amount of film. And of course, that made us very, very happy. And we figured, well, now we know how to do it. And so it came down, and it didn't hit exactly at the right place, which is another kind of story. The guy who had been at the aiming point on Discoverer 13 was there because he was the most proficient recovery pilot, and he and his crew had scored the highest in all the practices. And as a result of missing, he got thrown clear down to the end, which is where it came down. So he went from being a goat because he didn't catch it the first time to being a hero because he caught it down there 250 miles long, or at the very end of the recovery box or something like that. And so then we were really happy when that happened, and it came back and went through all the processes that it had to go. The sequence of getting things back was you picked it up out there and you put it in a can and you flew it here and you flew it there, and then they processed it and it went back to Washington. And then shortly after it was back there, then people got to go look at the stuff and tell us what a great thing it was. So we were real happy, and we thought, well, we really know how to do it now. and everybody was quite happy with that. Unfortunately, Discover 15, the doggone thing came down long again, and this time there was a problem in the command system. People, not technical. The thing went in the water. We had pararescue guys in an airplane willing to jump out of the airplane and pick it up, put it on a boat, on a raft, but they wouldn't let them do it. And by the time they finally got permission to do it, why, the thing sank. And then, and that was, unfortunately, that was the end of the Agena A, and then we started an Agena B program. And then we had to go through some of the same development things again because things went wrong with the Agena B until we finally got that worked out. And then our object was to get 2 in a row and then to get 3 in a row and finally to get it, as I said, where everything worked and the failure was the exception, not the rule, as it had been for the previous year and a half.
Great.
That was excellent.
Let's see, one of the things we've been doing, and I've got kind of an ulterior motive, just in case for some reason that Lee Battle isn't able to make it back. I want to be able to capture some things on tape that we can collate and maybe send over to him at some point in time. Why, would you characterize a little bit what you can say about Lee Battle?
Let me talk a little bit about Colonel Battle, because he was obviously the boss. And as far as we were concerned, he was the boss. He ran the entire program. Other people might write contracts, other people might think they did things, but really Colonel Battle was the boss, and he was the guy that people listened to, and he was the guy that people looked to. He was a very demanding boss. He wanted you to work hard, he wanted you to work smart, and he wanted you to do the things that he thought ought to be done. I had worked for him briefly before he became the director of the Discover program. Well, from February '58 until the time Discover was formed, and there were several things that you had to do. You had to have your arguments well in line when you went in to talk to him, and so you had to say, this is what I want to do, and this is why I want to do it. If you didn't know what you were talking about, then you were in terrible trouble. And he might not agree with you when you gave him the argument, but I guess I learned really early on, give him the best argument that you can the first time, and if the best argument doesn't sell, don't try to sell it on some secondary point, because that just gets you deeper in trouble. So make your point as well as you can, and if he says no, fine. Go away and hope that maybe he changes his mind on his own. He gave us really free rein of what we were supposed to do. I mean, he never did say, you shouldn't have done that, although he let you know of if you kind of screwed it up. But he gave us license to go ahead and do the things that we had to do, and he would back us up if there ever came to any trouble. Now, lots of other guys didn't like him. A lot of sporting organizations didn't like him because he was very demanding. And the people that worked in the office learned that very quickly, and that was that. I mean, it was the way we did business. He may have mellowed somewhat in recent years, but there was nothing mellow then. Another little tale. 2 guys from Harvard came out to interview a bunch of people about weapons systems acquisition, and they eventually wrote a big thick book. Their names were Fred Scherer, and I'm not sure what the other guy's name was. And they came in and interviewed him about how did he run things and so on and so on and so forth. And when he came out of his office, they were walking down the hall, and I was walking down behind them, and I heard one of them mutter and shake his head, and he said, "That guy's got all the power LeMay thinks he has." And that was essentially the way we did things. We had authority. We went ahead. We did things. We didn't ask for permission very much. It was, if you think it needs to be done, go ahead and do it. And if it's easier to apologize than to get permission, and we didn't do much apologizing as we went along. And I think everybody in the office recognized that thing. And it might irk us sometimes because we thought we had a real good idea. He didn't think it was. But we recognized that things worked better, and they really did work pretty well. As I say, the office was always very small. We spent an awful lot of time working on the right problem rather than on the wrong problem.
Great.
Excellent.
Super.
Very good.
Let's see.
I got a question, if I can. Did you have mapping cameras on that? When did you put those on?
Oh,
Certainly when we got to the gambit.
Yeah,
You had some.
okay, we
that
flew-
was a big problem because Schriever couldn't find out where he was with respect to the target. Go ahead. It's critical.
Bill, we put on something called the hell. DISIC. Now, DISIC was the second one. Dual. What's another word for mapping, Bill?
The only point I'm making is that
Yeah.
this was such a critical problem at the time. You know, the ballistic missile program is now becoming alive, and
Yeah.
we didn't
Okay.
know where the target was, we didn't know where we were.
What we did was we put on a small camera on the side of the main camera,
Yeah,
and it
that's
was
what
a stellar image camera. That's not the right acronym. Anyhow, this was a dual camera. It took a picture of the star field and it took a picture of the ground.
Right.
And with this, then they could say, and it operated at the same time that the main camera did. So you could relate the ground picture to a star field and to the ground, and that enabled you to pinpoint where on the Earth the particular targets were. Now that came in, it's hard to say. It was later on, but I don't know when it was. It may have been 61 or somewhere along there. And then as the program got more successful and went longer, then we put on two of them, one out of each side, so we could do that thing even better. That eventually led to the formation of all kinds of other things for the mapping purpose later on.
Yeah, in fact, that on text, and I think it was the same one on Corona, it was called the SQ, Stellar something system.
Well, yeah, we